I'll allow it.
Yeah, she
See here.
really wanted
And a
a
Dorman.
dog today.
That's right. That's right. All right, I'll get started here. Let me begin with a word of prayer. Hem. Heavenly Father, we thank you for this day. I thank you for these students. Again, I pray that you just guide our steps, help us to glorify you in what we do. I pray that the students, if they're struggling, they would just seek help, ask questions as they need to, and we just pray that you be glorified in what we do this day, Lord Jesus. In your name I pray. Amen. All right, let's get started on some examples here. So,
I have a question.
yeah, sure.
Before that. How did we arrive at pi?
How did we arrive at pi?
Yes.
Like who first defined pi?
Yes.
I don't know. I mean, it's the ratio of the circumference to the diameter of a circle. So, you know, it's in the Bible, approximated as 3, for what it's worth.
Okay.
Like in the descriptions of like the temple, you know, instruments and such, you know. Well, I don't want this. What am I doing? Stupid. No, I don't know. I remember offhand. But of course, some people be like, the Bible's wrong. It says pi is 3. It's like, that's not. I mean, first of all, there's the issue of like the inner radius versus the outer radius of the thing, blah, blah, blah. All right. I don't know when pi was first defined, actually. Okay, so example 1. See if we can solve this one. Minus 2x equals to 8y plus 18, and minus 33 equals to 7y minus 4x. Let's see if we can solve this system of equations. All right. So can you do it? How would you do it? Say again?
Wouldn't you have to rearrange one of them?
Rearrange one of them? Yeah, I think that's probably a good idea. Like y equals 1? Okay, so you're... So let me call this equation 1, let me call this equation 2. And so I think what you're telling me is to solve equation 2 for y, right? You want me to solve equation 1 for y? All right. For x? All right, fine, whatever. X is equal to 8y plus 18 divided by minus 2. Sure. Now what? Oh, if I must. Minus 4y plus minus 9, right?
Yes.
Okay, great. Now what?
Plug that into the other partial.
Now plug this into what? So we've got minus 33 equals to 7y minus 4 times x, but x is going to be replaced with minus 4y minus 9. All right, now we work it out, right? So we got minus 33, 7y plus 16y plus 36, which gives me minus 69 equals to 23y, which gives me y is minus 69 over 23, also known as minus 3. What's x equal to? Minus 4y minus 9, right? So that's minus 4 times minus 3, minus 9, also known as 12 minus 9, also known as 3. So my solution is 3 minus 3. Very good. You guys got that one, right? Okay, the method you guys just used is called substitution, all right? When you solve for one variable and plug it to the other equation, that's substitution. There's also something called elimination, all right? So let's look at elimination next. Example 2. Example 2, I will let us take a gander at 4x minus 3y equals to 25, and 3x plus 4y equals to minus 25. As is my custom, I'm going to label those equations 1 and 2. Here's equation 1, here's equation 2. So what we want to do elimination is you want to make something match up so we can cancel it, right? Multiply the first one by 3 and the second one by 4, you say. We can do that. Sure, why not? So that would give us 12x minus 9y equals to 3 times 25, which is 75.
Sorry, minus 30. First one.
Doesn't matter. Multiply second one by 4 is 12x plus 16y equals to minus 100. And the reason it doesn't matter is we can either add or subtract equations. So if we make them match up, then we subtract to eliminate. So then we subtract these equations. Let me give you guys a chance to catch up in your writing. So again, the goal in the multiplication is to, we multiply equations by numbers to make, something match up, right? So that they'll cancel out, so that they'll eliminate. And so when we subtract, we're left with minus 25y equals to 175, which says that y is 175 over minus 25, also known as minus 7. So y is equal to minus 7. What's x equal to? Let's see here. So we've got 3x plus 4y equals to minus 25. So if I plug this guy, right, into here, that gets me 3x minus 28 equals to minus 25, which gives me 3x is equal to 3, which means x is equal to 1. So I think I just plug the y equals 7 into one of the other equations, and it should do it for me. So my solution is 1 minus 7. So this is the elimination strategy, is to make two terms match up. You either add or subtract them to cancel them out. That leaves you one equation and one unknown, which you solve the way we did at the end of week 1 in this course. And then you plug back into one of the other equations to get the other half of it. That's all there is to it, right? For elimination. For substitution, you just take either one of the equations that you like, you solve for one of the variables, and you plug it into the other one, and then you solve that. So that's it for two equations and two unknowns. But let's work a harder problem before we move on here. Yeah, we'll do 3 equations and 3 unknowns soon enough. So example 3 for everybody will be this. We got 7x minus 1 over 5 plus y plus 16 over 6 equals to minus 27, and x plus 2 divided by 4 minus x minus y divided by 5 equals to 1. And it gives us a hint here. It says solve the system by elimination. First clear the denominators. All right? Yeah, multiply. Let me call this equation 1. Let me call this equation 2. So we should take equation 1 times, I heard 30. 30 times equation 1, and we should multiply 20 times equation 2. Right? because that will clear the fractions, right? So I'm going to do the fractions in my head if that's all right with you guys, and if it's not, I'm sorry. But thing is, when I multiply this equation by 30, think through it. What's 30 over 5? 6, right? So I write 6 times parentheses 7x minus 1. Then that 30 also multiplies by the 1/6. That gives me 5 times y plus 16. Now that's all equal to 30 times minus 27, right? And I guess that's minus 810, isn't it? Now, up next, the 20 times the second one, so I get 20 over 4 is 5, so 5 times x plus 2. And then 20 over 5 is 4, so minus 4 times x minus y. 20 times 1, I can do that one, 20. Then what? Then we need to clean it up, right? So let's clean up our mess here. We've got 42, 42x plus 5y equals to minus 800.
Why 5?
5.
What about 6?
Minus 6. Six times 7, x times minus 1.
Oh, I'm getting there. That's over here. Plus 6.
Oh.
I want the variables on this side. I'm putting my numbers over here.
Oh,
So I got my minus 810. Yeah, sorry. Hold on for a second here. So you're right, minus 6, but I add it to the other side. And this gives me 5 times 16, which is 80, but I subtract it to the other side. All right. We should all agree once we, clean things up here, yeah? So what we got? Minus 884, yeah? Agree? And then the next equation, I got myself 5x, right? Minus 4x, which just gives me x. And then how many y's do I get? Minus gives me plus 4y equals to, okay, I got 20. And then I subtract 10. So that's 10. All right. So I'm going to rewrite those over here. So what I've got 42x plus 5y equals to minus 884. And I've got myself an x plus 4y equals to 10, right? So let me give those names. Let's call those equations 3 and 4. How about that? Now what should I do? Hmm? Oh, you're trying to match up the y's?
Yeah.
You could do that, sure.
That's not as big of a number to multiply the top.
Yeah, I mean, we could do that. There's a lazier way here. Anybody see a lazier way? How about this? Why don't we had, actually we haven't used elimination yet, have we? So what I would do with this one, any time I look at an equation, two unknowns like this, and it's generally ugly, but there's like either a naked x or a y or a naked minus x or a minus y just sitting there, I'll use substitution because it's just easy. Like solve for x, right? It's like the whole point of elimination is to like eliminate a variable. But this one here, we can eliminate the variable just by writing this, right? X is equal to 10 minus 4y, right? I mean, I like what you were saying. You're right. I mean, an alternative thing we could do would be to like multiply by 42 and get 42x plus 4 times 42, 168y equals to 420. And then you could add these, right? Or subtract these. Like this is an alternative path you could go down. But anyway, let me just go here. So x is equal to 10 minus 4y. Then I take this, right? And I plug it into there, right? So 42 times 10 minus 4y plus 5y equals to minus 884. Which gives me what? Minus 168y plus 420 plus 5y equals to minus 884. You can almost see the arithmetic which we were about to get to in the upper right-hand corner happening to us whether we like it or not, right? Like all paths lead to the same arithmetic one way or another, you know? So this gives us minus 163y equals to minus 884 minus 420, which is otherwise known as minus 1304, I think. So y is minus 1304 divided by minus 163, which is obviously 8. Okay, I'll check it. 1304 divided by 163, 8. Yes, 8. I did work this problem in a previous section about an hour ago, so I do have that advantage, but you know, it is 8. X equals to 10 minus 4 times y, which is what? 10 minus 32, also known as minus 22. So solution is minus 22, 8. Es bueno.
Muy bueno.
Muy bueno. No habla español. That was not included in my Sesame Street. Let's see. Any questions? This one is kind of tough, right? I think this one's a little bit picky, isn't it? Let's work an example with 3 equations, all right? How do you solve 3 equations and 3 unknowns? I'll start us out with a super easy example. This example is really too easy almost, but it's a good place to start because it's so nice. Example 4. So I've got x plus y plus z equals to 3. I've got 2x plus y minus z equal to minus 6. And I've got x minus y plus z equal to 15. How do you solve 3 equations and 3 unknowns? 2 at a time? Kind of, sort of, yeah. So I'm going to label them 1, 2, and 3. Anyway, to solve these means we have to find a triple of numbers, right? We have to find a value for x, a value for y, and a value for z, that when we plug those in, all 3 equations are true, right? That's what it means to solve 3 equations and 3 unknowns.
Solve for y, you just solve for y by doing 2 and 3 together.
Oh, add 2 and 3 together is a very good idea, but it's better than you think. Add 2 and 3, what happens?
3y.
Oh, but it's not 3y. What happens when you add 2 and 3? Look at it. Look again.
The y cancels.
But not just that.
The z cancels.
The z cancels. That's why this problem is really, really easy. Because it's set up so that when you add the second and the third equation, See what happens? You just get 3x equals 2. 15 minus 6, yeah, which is 9. So x is equal to 9 over 3, also known as 3. It's like, what?
Just add the second and the third.
Yeah, we just add the second and third equations.
Wow.
Why? Oh, because if two equations are true, then you can add the left-hand sides and you can add the right-hand sides because that's a way we can combine equations.
Then why don't we just do it, why don't we just add all the equations and get the answer?
Because adding all the equations doesn't get the answer, it just makes a mess. I mean, it gets something. It gets you another equation, which is also true.
Oh, so what I got it.
It's the same game as before. The goal is elimination, right?
Yeah.
So you've heard that diversity is our strength, right? The elimination method is the opposite of that. We believe that diversity is not our strength. We want to eliminate all of the variables until there's just one kind remaining. So in that sense, math is racist. So I just thought of this. See here. I'm sorry, I'm just still on cloud nine. I mean, after Trump announced his candidacy, I'm just like, woohoo! I was so worried he wasn't going to run. He announced yesterday. I mean, let's be honest, he announced months ago. Wink, wink. The thing is, he's not my ideal candidate, but I don't personally believe that there exists someone else who can beat him in the primaries. Like, the people who voted for him are still going to vote for him. There is nothing. People are like, oh, he called DeSantis desanctimonious. That's going to really harm him. I'm like, no, that will do nothing to him. He remember what he said about McCain back in 2015? He said that he said he was a loser because he had to go to a POW camp because he got caught. That made McCain a loser. Like, he said that. It didn't damage him. His polls went up. This is not a man that can be damaged by saying wrong things. So, I don't know. I mean,
Edit that out of the video.
I don't think I need to edit that out. It's public knowledge.
Question,
So-
what do you think about
And besides, it is acceptable on YouTube to say negative things about Trump.
Oh, you're right.
I could say false things about Trump even. It would still be fine, you know?
what do you think about Ben Carson?
What do I think about Ben Carson? Is he alive? I don't know. Like, where is he? I haven't seen him talking anywhere. Is he talking here or something? Or was he in convocation? Did I miss it or something? Or okay. When did you get here? He did get. When did he get here? Yeah. No, I think Ben Carson had like the highest poll numbers here in 2015. Was it? I don't know. Oh. We're not done. Let's finish this. Sorry, it's my own fault. As I said, I'm just so giddy about Trump getting in the race. It's, you know. It's all Z's. It's all Z's. It's always Z. The 7 looks different. 7 is this. 7 Z. Z. I also do this for Z. You prefer that? That's a Z. This is 3. That's not that.
I mean, it's the same thing. Just carry on.
All right. I'm going to go on.
Can we finish, sir?
Can we finish this problem? Yeah, let's finish this problem. So how do I find x and y? Plug x in.
Or soft or Y?
So I need to,
Oh, yeah.
all right, I have everyone's attention. So let's add equations 1 and 2, see what happens. What's that? So I can do what? So I can get z the opposite way, right? It's not that I want to get z, I want to get rid of z.
That's what I meant by like getting.
Oh, you meant like get it.
Yeah.
Ah, I see. I got you. Let's see here. So 3x plus 2y equals to minus 3, right? Now what do I do? Well, now I've eliminated z, right? We already know x is what? 3, so we can take that, right? And we can plug that thing down in here. And that gets us 9 plus 2y equals minus 3, which gets us 2y is equal to minus 3 minus 9, which is 2y is equal to minus 12. So y equals 2? Yeah, minus 6. There we go. And then how do I find z? Well, you got choices, right? So we got x plus y plus z equals to 3, but x was 3, y was... z is that. So the 3's are canceling, and we get z equals 2? 6. So solution is 3, negative 6, 6. There you go. Oh, I agree. I mean, that's the funny thing, right? That example, example 4, I would argue, even though it's 3 equations and 3 unknowns, is easier than example 3, isn't it?
Yes.
I think it is. But usually, 3 equations and 3 unknowns is a formidable problem. Formidable. Like, it's going to mess you up. Let's see here. So, I need to, if you'll indulge me for a second here, I need to explain to you what does the general problem of m equations and m unknowns look like. Okay, so what's that look like? Something like this: a11x1 plus a12x2 plus dot 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 plus a1n xn equals to b1. The second equation, a21x1 plus a22x2 plus dot 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 plus a2n xn equals to b2. And then this goes on m-fold times, m as in mommy, n as in, there's n variables here, as in nenu nenu. M2x2 amn xn equals to bm. So this is the general problem: m equations and n unknowns. All right. Now we're only looking at special cases in here. We're only going to solve the case that m equals to n equals to either 2 or 3. That's all we're solving in here. All right, in terms of linear equations. So that's our focus. But I think I would be negligent to not tell you that you can solve this in general by the following calculator trick. Reduced row echelon form of the augmented coefficient matrix, which is a matrix which just peels the numbers off the equations and puts them in a box, like so. This dotted line is just for decoration. And so it turns out you can read off the solution from this calculation. And this is a standard thing you'll find in like your Texas Instrument calculator. There, you can even do this in the, I think you can, there is a way to do that math in this thing, but it is like, I don't know, it's, you know, like there's certain cheat codes for video games. It's kind of like that. Like, it's in there somewhere, but it's complicated. I don't know how to do it. What's a cheat code?
I'm a math major, so
Get out of here.
I know this.
Get out. You don't know what a cheat code is. I don't believe that. See here. Okay, so listen, this is the augmented coefficient matrix. This is a m by n plus 1 matrix. So this is the number of rows. This is the number of columns, all right? So listen, in past time, I have taught this material in college algebra. We actually go through what is a matrix and how to manipulate it and things like that. I have not included it in your current course, but I think it's important to mention as a point of mathematical literacy, this thing's called a matrix, and this is actually the way to solve it if you've got a lot of numbers and things, all right? And this is also a way you can check your homework. I'll show you in a bit here. Now, you might not see the need. If every example was like example 4, well, there'd be no need, right? Because that was easy. But example 5 is not. So example 5 here, it's not nice. So here, we are up against 4x plus 3y plus z equals minus 17, x minus 3y plus 2z equals minus 4, and 11x minus 2y plus 3z equals to minus 37. All right? Minus 17, minus 4. All right, so here we can't just, see, it doesn't matter how you add the equations. There's no sort of, oh, two things cancel out at once kind of deal like there was in the last one, right? Like there's no nice, just simple cancellation here, right? So we need a strategy for how to solve problems like this, problems which are ugly. And I have a strategy to share with you that will work. All right, so here's the strategy. So the strategy is this. Here's a roadmap. Number 1, eliminate z from 1 and 2. Eliminate z from 2 and 3. All right? So that's one thing we can do. Then step number 2, take the xy equations from 1 and solve them. There you go. That's it. That's the roadmap. So how do we eliminate z from 1 and 2? Multiply the first one by 2. 2 times 1 is 8x plus 6y plus 2z equals minus 34. Then we're up against x minus 3y plus 2z equals minus 4. So we want to subtract those, right? We subtract, the z's be canceling. And you get yourself 7x plus 9y. Minus a minus is plus 9y, the 2z's be canceling, and you got yourself a minus 30. Now this needs a name. Let us call it 4. Equation 4. Right? Keep that, save it for later. We'll come back to it, okay? Now, how do you eliminate? So at this point, what I've done is the first part, right? I just eliminated z from equations 1 and 2, yeah? So, oh, what do you know? So we just did that, right? Here we go. Now we want to eliminate z from equations 2 and 3. What should I do? So multiply the second one by 3 and the bottom one by 2. Very good. Very good. Exactly what we want to do. So we get 3x minus 9y plus 6z equals minus 12. And we get 22x minus 4y plus 6z equals to minus 74, yeah? Again, we're going to subtract them to eliminate the z term, right? So subtract these guys. So subtract, what do we get? 20 minus 19, right? Minus 19x minus 5y. The z terms cancel. And 74 minus 12 is 62. there you go. Let's call that equation 5. All right, so lo and behold, we just did this part. Now what? Take yeah, okay, so we take equations 4 and 5 and take our medicine, right? Like deal with those. I'll work that over here. Okay, I'm going to write them up here. So you got 7x plus 9y equals to minus 30, right? And minus, what was it, 19x minus 5y equals to 62. I'm calling those equations 4 and 5 respective, yeah? So what should I do? Substitution seems like a really annoying idea here. I think elimination's the way to go again. So to me, it's easier to make the y's match up, right? So I multiply equation 4 by 5. So 5 times equation 4. And I'm going to do 9 times equation 5 to make them both match up with a coefficient of 45 here. So like 5 times 7 is 35, x plus 45y. 5 times minus 30 is minus 150. 9 times 19 is 171. Minus 171x minus 45y. 9 times 62 is 558. And then this time we don't subtract, right? This time we add them because we've got plus minus on the coefficient we're eliminating. Right, so just add these equations. What happens? We get ourselves 136 minus 136x, yeah, equals to, what is this? 408. Is that right? Yeah. So x is equal to 408 divided by minus 136, also known as minus 3. You can check me.
For this before?
Hmm?
For this in the previous class?
Yeah, we're pretty fast. But I believe in book problems being nice too, so there's that. So if it looks like it's close to 3, it's probably 3. It is though. Now what do I do? Either use 4 or 5. I'll use 4. So I've got 7 times minus 3 plus 9 times what I don't know y equals minus 30, which gives me 9y is minus 30 plus 21, also known as minus 9, which tells me y equals to minus 1. And then pick your poison. Any of the first 3 equations, you go back, you plug in what you got. Ooh, I like equation 2. Equation 2 is nice, right? I don't know, it doesn't really matter, but what am I doing? No, I've got what? I've got x, I've got y. I should use which equation? There's a choice that'd be smarter. Use 1, right? Equation 1. That would be the smarter choice because then I've got an x, I've got a z just sitting there. So 4x plus 3y plus z minus 17. So my x was minus, so I got minus 12 plus 3 times minus 1 plus z equals minus 17, which says z is minus 17 plus 12 plus 3. Z is equal to minus 2. So my solution is minus 3, minus 1, minus 2. So yeah, I think this problem is formidable. The reason it's formidable is you guys are really bad at arithmetic. Right?
Could you, to be honest,
A little?
So it's accurate.
You feel attacked? Have I triggered you? I'm sorry, but hey, I'm also bad at arithmetic when I'm in a hurry and doing other stuff, right? Like, the thing is, you understand, to get this problem right, how many correct arithmetic steps you have to make? A couple dozen, right? It is just arithmetic, but you have to make all of those steps right, otherwise what you get at the end is wrong. Now, there is something, there is a silver lining here, which is once you get your solution, it's actually very easy to check it.
Plug it in.
You could just go back to the original equations, plug it in, and see if it works, right? So I'm not telling you this to say it's hopeless. I'm telling you this because if you're going to try to work these homework problems, you need to work them undistracted, right? And it's best if you can work with a friend that you can kind of like, you know, both work on the same problem and kind of like compare notes as you're doing it. Make sure you've got the right idea. Like, not a good idea to work these alone, I don't think. But hey, if you are working alone, I happen to know a friend that you can phone. Let me show you. It is not the Desmos. This is above Desmos pay grade. So, listen, this problem here, can I erase?
We're good.
Are you, is it okay? I kind of, sorry, I seem to have damaged. Look, so look, this has following coefficient matrix. This has, I want to look at the reduced row echelon form. This has the following matrix of numbers: 4, 3, 1, 1, minus 3, 2, 11, minus 2, 3, and then the last column, minus 17, minus 4, minus 37. So this is the B1, this is the B2, this is the B3 I was talking about here. M equals to 3, N equals to 3. All right? And this is the augmented coefficient matrix. It's a 3 by 4 matrix. All right? So let me show you. If you look at my website, although this is not technically not smart. I do have his permission to use it in my classes, but
Your brother?
no, my brother has not done this one. So, all right, so this, I'll show you how to get to this thing. It'll be over here. I've already got the numbers put in, but if you go to my website and you scroll down, eventually you'll get to where it says, come on, links to websites to do the math for you. Number 3 there, I have something that says calculates the RORF. Oh man, not that one. I can't, stupid finger. There we go. So in here, if you click on the third thing right there, that's what I want to use. So I already put the numbers in last class. Let me just make use of that over here. So I select 4 by 3 because it's a 4 by 3 matrix. That's the coefficient matrix that I have over here, right? And if I hit calculate, so show of hands, how many people in high school you did what are called row reductions? You looked at like a matrix of numbers, you added, you switched the things, you multiplied the matrix by number. You have some vague memory of this?
yeah, I do.
Yeah, that's the more efficient and correct way to solve these problems. It's a, you know, but I have not taught that to you guys this semester because it's a little bit more abstract and we don't really need it for the problems that we're solving, but that is the wiser way to do it. What this website does is it goes through all of the row reductions, step by step shows you them one at a time, right? One at a time, the row, you know, multiply the first row by a quarter, add -1 times the first row times the second row, and so forth and so on, right? And on and on. The thing is, all of these row operations, they correspond to the things we just did. They correspond to either multiplying the equation by a number or adding or subtracting equations. And the importance of those operations is that none of those operations change the solution set, right? So every time you do a row operation, you've got the same Thanks, guys. You've got the same solution set. So what that means is all of the equations that would be equivalent to the row operated ones are the same, like they have the same solution. So what I'm trying to say is it's a way of rewriting the system as a new system of equations. So this is equal to, see that? 1, 0, 0, 0, 1, 0, 0, 0, 1, the identity matrix, right? And then minus 3, minus 1, minus 2. What does this matrix mean? This matrix is equivalent to the following very silly system of equations, namely x, 1 times x plus 0 times y plus 0 times z equals minus 3, which of course we could just write as x equals to minus 3. The second one is y equals to minus 1. The third one is z equals to minus 2, which is exactly what we just found through blood, sweat, and tears and the elimination method, right? So you can check your answers with this. It also does 2 equations and 2 unknowns if you really want. And it is true. You could go back to, if you're going to use Wolfram Alpha to check your answers, do it like this. Check it out. So if I wanted to solve like x plus y equals to 10 and do comma, x minus 3y equals to 778. There you go. So there you go. Apparently the solution of x plus y equals to 10 and x minus 3y equals to 778 is 202 comma minus 192. And graphically speaking, there it be. So that's pretty much all I have to tell you about systems of equations. We could work more, right? But those are the techniques. Any questions? So next up, we're going to solve, well, there's a couple things that are coming up. The one thing, the next couple problems are applications. So like using systems of linear equations to find polynomials. Well, so that's like the next example I'll do. Past that, there are systems of nonlinear equations. I think I've got time for one of those right now. Oh, I do not. Oh, so I have just enough time to discuss Trump. So it's not that, I mean, I have a lot of love for Trump. I mean, he did some things that were very good, but he's also an incredible distraction, I think. But the thing is, I just don't believe anybody's going to beat him in the primary. We say whatever we want, but I don't think it's going to happen.
If DeSantis was his VP,
If DeSantis was his VP? Yeah, I don't think that would work. We do have class on Friday. If you, oh, before you guys disappear,